We have here a block of mass m, and it's connected to two springs having spring constants k1 and k2. It is displaced by a distance x and then released. What will be its initial acceleration? So from the mean position, this block is disturbed by a distance x. It's given a displacement x, and so let's assume that it is displaced to the right. So the K1 spring, that is elongated by a distance x, and the K2 spring is compressed by a distance x. So this first spring, this K1 spring, since you have elongated it, it will try to apply a force opposite to this. So now it will apply a force of negative K1x on this. And if this is the positive direction, as we just thought about it. And the second spring, the K2 spring, if it is being compressed, it will try to elongate itself to the natural position. And so it will again apply a force on the left hand side again, so that its magnitude, we would write it as negative of K2x, since x the displacement. And so the sum of all the forces acting on this block, that will be equal to negative K1x from the first spring and negative K2x from the second spring. And this is equal to the mass of this object, so that is m, times the acceleration, the initial acceleration that we need to find. And the reason why there is an initial acceleration is because after t equals 0, it will oscillate in a simple harmonic motion that we don't need to consider right now. So for now, what you can do is you can take the negative common, and so you get this. And to get the acceleration, what you can do is you can just divide both sides by m, and you would arrive at acceleration being equal to negative of k1x plus k2x over m. Even better, what you can do is you can take x common out, and so you would arrive at a to be equal to negative of k1 plus k2 over m times x. What does this negative sign mean? This means that in the direction that you displace x, so in this case we displaced x to the right direction, the acceleration is in opposite direction of it, so it's in the left direction of it. If we would have displaced m to the left direction, the acceleration would have been to the right direction.